Modern enterprises must secure a distributed workforce that uses a plethora of devices without hindering productivity. Support both modern and traditional workloads running in diverse cloud environments, and keep up with evolving networks used to connect everything. This results in too many surfaces to defend, too many silos, and too little context. But comprehensive security is complicated, resource-intensive, and volatile. How can you accelerate your zero-trust journey for a more robust security posture? VMware delivers simpler, faster, and smarter security that effectively spans your distributed workforce and applications. Let's see how VMware helps you rethink security and simplify your zero-trust journey. With everything dispersed and constantly changing, the deployment and management of traditional agent and security controls to monitor and protect your environment becomes infinitely more difficult. Your security posture needs to mirror your infrastructure. With VMware, your security controls and policy enforcement protect your distributed assets, supporting both new and legacy environments and applications. And because you can reduce the number of tools and agents you deploy while managing them in a centralized fashion, you can consistently apply your policies across multiple environments with little to no added effort. You achieve full coverage of your environment by connecting the dots, while reducing complexity and blind spots. Security, IT, and operations teams approach security from different perspectives and with different tools, generating unique, often isolated data. VMware connects your zero-trust control points, enabling you to accurately understand the security situation and enforce the appropriate policies and actions to close security gaps and reduce risk. With greater coordination between your security, IT, operations, and development teams, powered by a common concept of what they are protecting and the steps required, your people can act faster with greater efficiency. And with fewer security products, you spend less time on administrivia. You'll have the right zero-trust strategy in place to ensure no vital area is left undefended. Smart security decisions require more than threat intelligence. You need complete, accurate data and a deeper understanding of how your applications, data, network, and users work together. VMware gives you risk mitigation confidence with behavior-informed authoritative context, intelligent risk correlation with proactive prevention, detection, and response, and threat intelligence to surgically remediate threats and proactively reduce risk exposure. And you can deliver a secure and seamless employee experience with our context-aware security features, combined with cloud-first device management. Robust, yet simplified. VMware delivers simpler, faster, and smarter security. VMware offers all this and more, simplifying your zero-trust journey for your modern, distributed enterprise. Learn more at vmware.com/security.
Hello, everybody. Thank you for joining me here today. Now, today I'm going to talk about the risk and the challenges in leveraging the Metaverse to achieve your business outcomes. Now, we all know roughly what the Metaverse is all about, right? So when you slap on the goggles, the virtual reality goggles, you'll be transported into a virtual reality world where you can do many, many different things. You could potentially be shopping, right? You could also potentially be conducting a meeting with all your colleagues from all different corners of the world. And you could also be joining a conference or joining an event that's happening halfway around the world at the comforts of your own home. Now, as you can see, you can probably do almost anything in the real world. You can do it in the Metaverse as well. So that is why a lot of companies, a lot of businesses out there are trying to see whether can they leverage the Metaverse to help them reach out to their customers to better serve their customers. Now, Gartner came up with these elements of a Metaverse just to highlight some of the key components of the Metaverse. Now, as you can see from all the elements here, they are pretty, these are all the usual suspects. Now, but the key thing is this, right? Each of the elements here, they share one very common and important fact. All of them actually sits on top or sits inside an application. Now, with any application, you have all your various users. You have the users coming in and accessing the application through their virtual reality goggles or whatever tools they're using. You have the developers as well. They are constantly accessing the application to update it, to upgrade it, and to constantly build upon it. Now you will realize all these things now sit on top of a infrastructure. Now this infrastructure is basically where you provide the necessary resources to host the application. The resources include compute resources, storage resources, and also the network connectivity as well. Now, all these resources can sit in a private cloud or in public clouds. And all these are meant so that you can host the application in any different types of environments you have. Okay. Now, this infrastructure is also used to connect all your different users around the world to access the applications. The infrastructure also provides connectivity for all your developers sitting all around the world to connect into the applications as well, to do the constant monitoring and upgrades and adding on new feature and functionality as well. So if you're seriously trying to leverage on the metaverse to try and improve the way you engage customers, achieve all the various business outcomes, then you definitely have to first consider building this infrastructure and making sure that it's highly secure and highly reliable. So before we can do that, we have to understand then how is the application being developed and built today. Now, in the past, an application used to consist of just a few virtual machines. Now, within the virtual machines, you have the different function of the application. Like, if, for example, here, one of the virtual machines could be hosting your web front end. Another virtual machine could be hosting the application itself. And then basically, another virtual machine could be the database. And all these will sit together in one single node. Now, usually all these virtual machines will sit inside one data center. But the modern applications today behave more like a very highly distributed system. You realize that the components of the applications gets broken up into many, many different smaller functions. One of them could be sitting in a microservices, sitting inside a container within the Kubernetes clusters. The rest could simply sit inside virtual machines, but all the various components could be sitting in the data center in the same data center, or it could be sitting in data centers, public cloud, private clouds all around the world. So that's why once we understand that modern apps is distributed in this manner, we can understand then how we can build a infrastructure to connect all these functions together and also make sure that we can secure it as well. Now, in order to secure such an infrastructure, we first have to understand one fundamental concept, something called the zero trust. Now, zero trust, well, in essence, it's not a product. It's actually what we call a security methodology, right? It's the way you implement, it's a design principle in security. So essentially what it means is this: trust nothing, verify everything. So in other words, if you want to build this methodology into your security strategy, you must make sure that you have all the right security controls to be always constantly doing the monitoring and then basically doing the constant checking as well. The controls definitely you put into the various areas like your devices, your people, your workloads, and also your networks. Essentially what we'll do is that we bring all these things together, and then basically from there, you will see how all these controls actually work together and constantly share information with each other. For example, the endpoint, if the controls in the endpoint, for example, is able to detect something that's not right, is able to share information to the controls over at the network side so that they can implement certain policies to isolate that particular endpoint. So information is being shared this way so that the system can actually act accordingly to mitigate the security breach. This is how all the zero trust components come together in these key pillars that we highlight here. Of course, then we will wrap it round with all the visibility and analytics capabilities, and also from the automation and orchestration perspective as well. So what that means is that we give you the capabilities to be able to build the policies as granular as possible. We give you tools to be able to automate the whole process. And then basically once we push down the rules and the security policies to each of the control points, we now are able to have tools for you to be able to have visibility and analyze all the data that comes out of it. So these are the key pillars of zero trust. Okay. Now, there are three major obstacles basically that makes it very difficult to implement zero trust. One of them definitely is you cannot secure what you don't understand because there's just too little context. There's also too many silos because your different control points, your workload, your network, your endpoints, all have different sets of tools, different teams working on it, and each one behave as a silo and they don't share information. There's also too many services to defend, and once you have too many services, it's difficult to instrument and control. So what do I mean by all these obstacles? Let's dive a little bit deeper. Okay. When I say too little context, what it means is very simple, right? Let's take, for example, a workload. If all you know about the workload is just an IP address, then for all the different types of attacks coming in, if the attack is particularly focused on Windows machines, for example, and all the information you have of the workload is just a simple IP address, you wouldn't know how this attack would impact the machines. You wouldn't know which one of them is vulnerable, which means that you are not able to fine-tune your security policies to offer that particular set of protection to protect against that particular attack. So you need more information. Having more information outside of just the IP address. For example, if you know that this is a Linux machine running in Linux OS, is running a certain application with all these processes in there. All this information gives you context so that you know what you're defending, so that all the attacks that's coming in, you're defending against it, you know exactly which one of your assets are vulnerable, and then you can tune the policies accordingly. But for now, for the most case, if you have too little context, it's too difficult for you to apply the zero trust principles to what you're doing today. Now, the other problem is that too many silos, right? Now, in your team, I would suspect that possibly you have your infra team, your end user team, your infosec team, your developer team. You even have your identity team and your network teams. You have multiple teams within the organization. Each one of them focus on a very specific environment, each one employing tools to protect that particular environment. But all these tools and teams all behave and then separately, they work in silos, which means they don't share information. And once you don't share information, again, the concept of zero trust is broken again as well. Okay. Now, too many services to defend. Well, in the past, what used to be when you want to access corporate information, corporate application, one would use a corporate issued notebook. Then you will come to the office and connect to the office network. And then you log in and then you access the office application. That was usually how you do it. The number of attack services is well defined. But now in this current day and age, what happens is that your users would like to use their own devices. They want to be able to come in and access applications regardless of where they are, whether they are at home, branch offices, whether sitting in a cafe or whatever. So there's many different areas to protect, and they not necessarily only want to access the application you have in your corporate data center. They also make use of all those SaaS-based applications like Salesforce.com, Office 365, and then those are also additional services that you need to defend as well. If you look over to the data center, for example, right, the same is happening to the workloads that sit inside the data center. The workloads today typically do not just exist in one location, right? The workloads can either exist and sit inside your local data center, your private cloud, your public cloud, and in your many different flavors of those public cloud as well. So in order for you to fully protect the workloads, there's all these different services that you need to implement the controls and to be able to instrument them. It's just too many of them today. And if you have too many of them, it's very difficult for you to enforce or apply the zero trust design principles into the security strategy. Now, what can you do about this? Having known all the challenges, what can you do to effectively deploy and have a security strategy based on zero trust? Well, so VMware can definitely help. So what VMware did is to build a security strategy specifically on zero trust. And what it does is three very simple things. One is on the situational intelligence. Okay, what this means is that we give you more context, more information about the resources you're trying to protect, and all this information are built natively into the solution itself. We make sure that all the different control points are connected to each other. They can share information. so that we know for sure that we are able to have a more holistic view of all the control points. Then, of course, we treat security as a distributed service. That means basically we make sure that we have the security capabilities as close to the various assets that we're trying to protect as much as possible. Okay, let me go a bit deeper into what I mean. Okay, now in order to implement this, what we call the intrinsic security, this is a set of solutions that VMware has that can help you introduce all these capabilities into the infrastructure itself. If you see, these are called the 5 common control points: the endpoint, the access, the network, workload, and then cloud. Let's first look at the endpoints. Now with endpoints, we have the carbon black solution. Basically, the carbon black solution is an endpoint solution. It's an agent that sits inside your endpoint, and it helps the InfoSec team identify, prevent, detect, and respond to threats at the endpoints. Okay. Next, we have the VMware Firewall, the Advanced Threat Protection, and also the SASE platform. What this does is that it helps the networking team, for example, control network access, enforce certain type of network protection by inspecting the traffic itself. And it also does one very, very important thing, which is micro-segmentation. It helps to break the network into smaller components, and with smaller components or smaller segments. And within the segment itself, it implements control so that it makes sure that assets or endpoints or workloads within the segment cannot talk to each other unless it passes through some access controls. So these are what the capabilities that's introduced that specifically to help the networking team. Next, we look at the access. Then you have solutions like the VMware Workspace ONE that can help the end user team manage posture and access of the various devices that they want to use, and also the identity of the users that are trying to access your application and your data. Then last but not least, of course, we take a look at the cloud as well. So we have the VMware Cloud Health Secure State. Now, what it does is basically it helps your cloud operations team securely configure your cloud infrastructure, and then it makes sure that basically the configuration of all the capabilities in the cloud conforms to a certain compliance and conform to a certain standard, so that there's no misconfiguration at all. So as you can see here, all these various capabilities that's important to each and every one of the teams here, there's a capability to help them. And the key thing is all these capabilities, all these control points are built into the infrastructure, and they all can share information and talk to each other from there. Okay, so this is what VMware, in terms of our strategy, is what we can do for the customer, each one of you actually. Okay, now, again, we will wrap around all the tools that help you visualize, analyze all the data, and also we give you capabilities to automatically automate the process of pushing down the rules and then orchestrate all these things as well. Okay, now what this means is when you implemented all this, what we have done is that we managed to secure your infrastructure in a way such that because of all this intrinsic security and solution, you now have an infrastructure that you can confidently and securely run any application, whether they're built on the traditional way, whether they're cloud natives that sits inside containers that sit inside the cloud, or even the SaaS-based application. You can run any application on top of this infrastructure. You can allow your corporate users to use any device to come in and access the application. Okay, and then all these applications can be sitting inside the hybrid, any form of cloud, public or private. It can be a telco cloud as well, or you can sit in one of your edge branch network as well. Okay, so with essentially the capabilities that we've introduced, it allows you to build that infrastructure with all this security all built into the infrastructure. Okay, to give you a better example of what we mean by situational intelligence and also the connected control points, for example, right? So in an environment like what you see here in the data center, you'll see things like the virtual machines are connected with each other. You will see, for example, you'll see here, each of the virtual machine is actually fronted by what we call a distributed firewall. Now, this firewall is actually built into the kernel of the hypervisor. This firewall is considered an individual firewall, and it sits directly in front of a virtual machine, which means that traffic coming out of the virtual machine has to hit the firewall first before it even touches the virtual switches. All this firewall, you can put in a very individual and unique security policy on a per VM basis. Now, this is how close how integrated you can get in terms of how you can place a controls protecting all your various resources you have. Now, on top of that, we make sure that all the control points, basically they start sharing information, which means today, we all fully understand all the the virtual machine attributes. We understand all the network attributes because those are virtual switches. We can even understand all the different application attributes itself, and we can combine them together to help you build policies based on these attributes, and then you can push it down to the individual firewall. A typical example, for example, would be, you can say, well, I want to make sure that are all Windows 2003, all servers running Windows 2003 cannot access the internet. So a policy like this, to be able to translate it into a firewall policy, now we have information like, for example, which virtual machine is running Windows. We know that. These virtual machines are connected to which virtual switch port. We know that as well. And then we know each virtual machine running Windows, what application running in those. So we can apply this policy specifically to that particular VMs that is part of this group and not anywhere else. So we allow you to be able to control it that way. And we can do this without having to re-engineer your entire network infrastructure, because we don't change all your IP addressing. All the firewalls introduced is considered like a bump in the wire, where traffic just simply flows through, and then we inspect that accordingly. So this is what we mean by situational intelligence, and making sure that all the control points, the attributes of these control points, we can use it and share it together to give you a more granular set of policies that you can implement. Now, if you were to leverage on things like the PCI compliance, for example, we can actually help you segment a part of the traffic, part of the network for all the resources that has to go through the audits, and then we make sure we configure the right sets of policies for this set of resources that can help you comply to PCI as well. So we can do that because we have, again, it's about situation. We know the context, we know about PCI requirements, we help you configure the right policies for all these things. Now, remember we talked about the security being a distributed service. Now, here's what we mean. Now, under normal circumstances, if you were to look at your data center, for example, you'll probably see racks and racks of servers where the application sits. Then you will also have racks and racks of security appliances like your firewall, your IDS, IPS, and also your load balancers. Usually what we will do is that if an application on one server wants to talk to another application on another server, traffic has to come out of the server, goes to the firewall for inspection, and then come back into the other server again. Now, there's always this constant hairpinning of traffic going on. It's highly inefficient, okay? What we can do when we start to distribute the capabilities is we take the firewall capabilities, we distribute it to each and every one of the servers. You probably saw an example of it just now, whereby each firewall is now sitting in front of every virtual machine. We take the IDS, IPS capabilities as well. We distribute it into each of the servers. We do the same thing for the load balancers and the web application firewall. Okay, so now we put all the security services into each of the servers to make sure that all these capabilities are now as close to the assets you're trying to protect as possible. Then all capabilities are processed within the server. There's no longer any hairpinning of the traffic. Now, the last piece of the puzzle is the analytics capabilities. As opposed to having racks and racks of servers to do that, we've push all these capabilities also into the servers themselves, so that all these capabilities is highly distributed into each of the servers. Okay. Now, whenever we need new resources, we add in new servers. Indirectly, we are adding new capabilities to run all these things as well. So it's highly scalable, and then it's very effective in helping you control all the various type of traffic that goes in and out of the servers themselves. So this is what we mean, when we say in this day and age, because the applications themselves are so distributed, the security services that you want to apply, the security capabilities, must be distributed in the same manner as well, so that we can do the necessary inspection as close to the endpoints as we possibly can. Okay, so now with all this in place, right, you realize that you understand fully what the challenges are. You understand now how VMware, based on our security strategy, can address those challenges. So essentially now what you have is a security strategy that's more effective. Okay, so basically you are able now to take the right action with confidence, because with the right intelligence information, with the right context, you now know that when a breach happens, you know that the breach is the real one. You know how to take the right efforts to mitigate that attack. It is more efficient because basically now you reduce the number of tools that you have, because certain tools can be shared between different teams. So you have lesser tools, which means that now you can implement a zero trust principle across teams that know with lesser tools, and remove all the silos and all the operational overheads from there. And finally, of course, more coverage. Because all our capabilities are fully distributed, they can be distributed to anywhere that requires the coverage. So now we can secure that we have security that basically follows exactly where your users are, where your data sits, and where your application sits as well. Now, with all these benefits, you can now confidently say that you are able to now reduce the amount of risk in terms of security when you try to build the necessary applications so that you can try to leverage on Metaverse to be able to build your business outcome from there. Thank you very much. Thank you for joining me here today. Thank you.